Hey guys, we're just going to go ahead and finish up one quick question on the notes. I thought it'd be valuable to see how imaginary numbers tie in with the first target from this chapter, which was solving with square roots. So anyway, you have two questions at the very end, questions 28 and questions 29. This is on page 87, I believe. And so we're just going to do the last problem here. If I'm looking to go ahead and start solving this problem, getting rid of this 2 first by subtracting is going to be our first step. I could probably divide by the -3, but then when I divide the 2 by that same amount, it becomes a fraction. Not too fun to work with, so 44 minus 2 is probably the best way to go. Otherwise, after we go ahead and subtract 2 from both sides, never ever distribute. That would be wrong. And that's because the exponent is the piece of information that's in charge. And so I really just want to go ahead and divide by -3 first. Make sure you get the negative on both sides so they cancel. 42 divided by -3, I believe, is 16. -16 equals x minus 2 in parentheses squared. And this is where we can go ahead, we can square root both sides. Now the moment that we just put a square root sign over a negative, this is going to be imaginary, okay? And that is something to really be aware of, okay? The negative here becomes I itself. Otherwise, square root of 16 is pretty easy, it's 4. But we're dealing with not 4, I is what we're dealing with. The other side, x minus 2, don't forget that has to go inside absolute value bars. We're going to go ahead and we're going to get rid of those bars by making the other side plus or minus. The same rules still apply, even though it's an imaginary number. And add 2, and you got to make sure you're adding 2 to the right spot. X in the end is 2 plus or minus 4i. This is our answer. You have to make sure, do not take 2 plus 4i, that doesn't make 6i, and don't do 2 minus 4i to get excuse me, another answer. These are complex answers. 2 plus 4i is complex, 2 minus 4i is complex. What's really interesting about these two answers is if you plug them in, back up for the variable, the 2 that's in each answer and the -2 cancel. And so you're left with the 4i or the -4i part. When you square those things, you get 16i squared, and 16i squared is -16. -16 times this -3, and then if I add 2, will come out to be the 44 that I wanted in the end. So it does check, even though it's a complex number. You just have some more math stuff to do to get there. So, hope that helps. Your homework would be a great thing for you guys to work on, to double check with each other and kind of wrestle through with how imaginary numbers work in a lot of different scenarios. The better you are now with imaginary numbers, the faster some of our upcoming problems will go, because you don't really have to think about them. You don't have to stop and remember how to do imaginary numbers. It's already built in. That being said, after the homework, if you finish that and you've turned it in, I have a fun maze activity that if you start at the top, and every time you come across a problem, you need to solve that problem and then kind of look at the different answers that are right next to that problem and choose the path that has the appropriate answer, and it will eventually lead you to the finish line down at the bottom of the paper. I think that's going to be a lot of fun, and it's another good way to get more practice problems in. Otherwise, we'll see you guys tomorrow, and hope that you guys all have a great day. Take care, everybody.